At this time, we are going to see about the near and far field region related to the antenna. So when a signal is transmitted from the transmitter or it is applied to the antenna, it has to be transmitted or propagated in terms of EM waves into the free space or air. So, in order to study the property how it propagates through the air or free space, we have to draw the EM characteristics as a function of distance from the antenna. So, the graphical representation of EM field characteristics are the propagation of EM field by the antenna as a function of distance is called as radiation pattern. So how, for example, if we give the input to the a particular antenna, how it radiate, and what about the field strength, and what about the field strength variation depending upon the distance, that we are going to see in this video. So that are all called as near and far field region. So field region, it is nothing but the distance that is covered by the particular antenna by its propagation. So it is broadly classified into two regions, that is near field and far field region. First we will see what is far field, near field region. So from the name itself we can able to understand that it is near fields, right? So when we place the antenna, what about the region that is covered which are all very near to the antenna location, that is called as near field. So we have the formula, or we have some criteria value to divide the near field and far field, that we will see in later. First, near field region, it is a region which is very nearer to the antenna and it is called as near field, and it is also called as inductive field, right? So the near field is called as inductive field, because it has the inductive effect. So the near field region, it is a region just right next to the antenna. So from the criteria point of view, here the near field can be defined up to the point it is less than to equal to 2d square divided by lambda, where d is the linear dimension of the antenna and lambda is the wavelength. And here again the near field itself, it is divided into two parts. One is a reactive near field and radiative near field. Reactive near field, from the name itself you can able to understand the antenna can able to react, but it cannot do the effective radiation. That's why it is called as reactive near field. So it is a region that is adjacent to the antenna. So in this region both E field and H fields are 90-degree out of phase. But if you want to get the effective radiation from the particular antenna, what is the condition? So both the E and H field has to be in phase to each other, right? Since it is 90-degree out of phase, and therefore it is reactive. So to radiate to radiate or propagate the EF field by the antenna, it should be orthogonal, and both should be E field and H field should be in phase with each other. So what is reactive field? It is a field which is very near to the antenna. It is called as reactive or non-radiative field. So here the formula or to identify the reactive near field within the near field is, so the distance which is less than 0.62 into root of d cube divided by lambda, it is called as reactive near field. Then next near field, it is radiative near field. So the region which is also called as Fresnel region, it is actually the the distance at which the antenna starts to radiate effectively, which is called as Fresnel region. It is a region between the reactive near field and the far field. So whatever the in between region we have between the non-radiative and the effective radiative or the far field, it is called as reactive near field, and this is a region where the EM fields starts to transition from reactive to the radiative field. So it is obviously it is a transition region between the non-radiative and the radiative field. So non-radiative field is the reactive field and radiative field is nothing but the far field. So in this region the field distribution is independent of the distance from the antenna. So by formula, in order to identify the reactive near field, it is from 0.62 root of d cube divided by lambda and to 2d square divided by lambda. So the region in between these two values, it is called as radiative near field. And the next major field, it is called as far field region or the Fraunhofer region. So it is actually the region surrounding the reactive and radiative near field region as we have seen so far. So it is extended to infinity, right? So wherever, so it is simply we can say that whenever we want to measure the radiation property of a particular antenna, it is advisable to take the measurement in the far field region only. So in this region only we can have the considerable or the effective radiation from the antenna. So it is extended to infinity and it represents the vast majority space the wave usually travels, right? So the electric and magnetic field in these regions are in phase and it perpendicular to each other and perpendicular to the direction of propagation also. So the distance from the antenna must be much greater than the size of the antenna and the wavelength. So to define the location or to identify the far field region, here the formula used is the region which is greater than 2d squared by lambda, it is called as far field region. So here this is the another pictorial representation which explains the near field and far field. So this is the antenna location. So this is the symbol for antenna which is used for RFID application. So here the first one very nearer to the antenna location, it is called as reactive. After that you will be having the radiation which is in between the reactive and the far field region. So this reactive and radiating region combined together it is called as near field region, and the far away location, right, that is called as far field region. This is also the another pictorial representation where we can classify the near field and far field. So here in this near field very nearer to the antenna location it is called as non-radiative, where the E and H field are 90 degree to each other. So the net field it is not in the considerable amount, that's why it is called as reactive field, where whenever the distance from the antenna is moved away from the location, so here the cancellation or the phase difference is wider, so the cancellation is limited, that's why you will be having the radiation started in the Fresnel region and you will be having the considerable radiation in the far field region also, far field region only. So this is all about the near and far field region of the antenna. In the next class we will see the radiation pattern characteristics of the particular antenna. Thank you.